I've written down the formal definitions for ordinal addition and ordinal multiplication. And what I'd like to do is give you some additional practice seeing them in action. So I'm going to perform some computations. I'm going to start with addition, and then I'm going to use the results of our ordinal addition to perform some ordinal multiplication. So let's start by seeing what omega plus omega is. Omega is a limit ordinal. So of the three clauses in our definition of ordinal addition, we need to look at the third one, which corresponds to the case in which what we add to alpha is a limit ordinal. So by our third identity, omega plus omega is omega plus beta for beta smaller than omega. And of course, the ordinals smaller than omega are just the finite ordinals. So that set is just this one. And a different way of writing that set is just this. Oh, I made a mistake here. Sorry about that. And so forth. And the way to see that is to again look at the definition of ordinal addition. So omega plus 0 by the first clause is just omega. Omega plus 1 by the second clause is omega plus 0 prime, which by the result we just proved is omega prime. Omega plus 2 is omega plus 1 prime, which by the result we just proved is omega double prime, and so forth. So that's how we get from here to here. And now remember that unions are just the result of pooling together all the elements of the members in our set. So we start with the members of omega, which are 0, 1, 2, etc. And then we pool in the members of omega prime, which are all of those plus omega. And then the members of omega double prime, which are all of those plus omega prime, and so forth. So we now know what omega plus omega is. It's all the finite ordinals plus omega plus the result of adding some finite number of primes to omega. So let's now use this result to perform a multiplication. Let's multiply omega times 2. We need to use our second clause for multiplication because 2 is a successor ordinal. So by our second clause, omega times 2 is omega times 1 plus omega. And then what about omega times 1? Well, again, by our second clause, that's going to be omega times 0 plus omega. And then we add the omega that we had from before. And what about omega times 0? Well, by our first clause, that's just 0. So we get 0 plus omega, which is just omega plus omega. And by our previous result, we know what omega plus omega is. It's just the set of finite ordinals plus omega plus the result of adding finitely many primes to omega. So by combining the two definitions, we've now managed to derive the contents of omega times 2. So let's see if we can keep going. So what we've done so far is shown that omega times 2 is omega plus omega, which is this set. The finite ordinals, omega, omega prime, and so forth for a finite number of primes. Using a similar procedure, we could show that omega times 3 is omega plus omega plus omega, which is going to be the set that starts just like this one, but then after every element of this set includes omega plus omega, and then it keeps going. So omega plus omega, omega plus omega prime, double prime, and so forth, again for finitely many primes. And we could do the same for omega times 4, and 5 and 6, and so forth. Now, what about omega times omega? Well, that'll give us a chance to look at the third clause in our definition of ordinal multiplication, which corresponds to the case where we adding to alpha is a limit ordinal. So by our third clause, omega times omega is the union of the set omega times beta for beta smaller than omega. In other words, for beta, a finite ordinal. And that's just the set omega times 0, omega times 1, omega times 2, and so forth. And happily, most of these sets are precisely the ones we've defined before. We haven't defined the first two before, but it's very easy to see what those are. So by the first clause of multiplication, omega plus 0 is just 0. By the second clause of multiplication, omega times 1 is omega times 0, which is 0, plus omega, which is just omega. And then from this point on, we've actually managed to derive what these sets are. So we have omega plus omega, omega plus omega plus omega, and so forth. And remember, the union of a set is just a result of pooling together all the elements of members of the set. So when we pool these together, we start with 0, which has nothing. Then we add everything in omega, which is 0, 1, and so forth. Then everything in omega plus omega, that's all of those. And then omega, omega prime, and so forth. Then everything in omega plus omega plus omega, that's all of those. And then omega plus omega, then omega plus omega prime, double prime, and so forth. And as we keep going, we're going to then add omega plus omega plus omega, then omega plus omega plus omega prime, and so forth. So we've now used our formal definitions of ordinal addition and multiplication to explicitly spell out what omega times omega is.